Here is an unusual little power supply I found at the thrift store. The price tag says $10.49, but they had a 50% off sale, so I got it for about $6, including tax. On the front it has a voltage meter reading 0 to 15 volts and a voltage adjustment knob, so nothing unusual there. But this labeling doesn't quite make sense. Porkit indicate tattoo power supply. Well, I understand tattoo and power supply, but I have no idea what it means by porkit indicate. On the back is a permanently attached grounded AC power cord, a power switch, a fuse, and a label. It says tattoo power supply. Input AC 110 volts 50 to 60 hertz. Output DC 1.5 to 15 volts 2 amps. And on the top is this painted on company logo and stripe, which wasn't even put on correctly. It's misaligned and not even straight. It says Inkstar. And this is obviously just painted on the metal cabinet. In fact, when I started to remove the price tag, the ink or paint came off along with the price tag. So, yeah, that's not very professional. After a few minutes of web searching, some of this is starting to make sense to me, while the rest of it is still a mystery. These two 1/4-inch jacks labeled liner and foot. The liner output is the voltage output, because I discovered there's two main types of tattoo guns. Two different types of needles they use. A liner needle and I forget what the other one's called, but all we need to know is this was designed for a liner needle tattoo gun. And the foot jack is for a foot switch. So you push on the foot switch when you want it to output the voltage, and when you let go, it stops. So this is really just a contact closure to turn on and off the output. And this is the output. They're both 1/4-inch jacks, just like ordinary audio jacks, except in this case used for a power supply. The part that does not make sense is this label here, porkit indicate. I tried looking that up. The only thing that comes up is this exact power supply, and they're just repeating what it says on the label, including this, what I assume is some kind of typo, but even if it was supposed to say pocket indicate, that still doesn't make any sense. Okay, I remember it now. Liner and shader are the two main types of tattoo gun needles. So this one was designed for use with a liner gun needle as opposed to a shader gun needle. And that's pretty much it for the external tour of this power supply. There's nothing really else notable about it except for a little sticker on the bottom that says C. In fact, a few other things are notable by their omission. Any indication of a manufacturer or model number or where this thing was made. It's a mystery. And it does seem to work. When I plug it in, turn it on, the meter lights up, and these two LEDs light up. And as I adjust the knob, the meter reading changes correspondingly, though that's a very bouncy needle meter. It swings rather wildly, so it may not be that accurate, but it seems to vary between 1 volt on the meter reading and maybe 16 volts off the scale slightly. And if I use this Samsung SEL906 Hi8 camcorder's mirror effect, it now turns into a dual meter power supply. That's freaky. It almost looks like AI generated that. So now let's actually hook this thing up and see if it's putting out the voltage it claims to be putting out. Actually, first I just need some way to hook this thing up because 1/4-inch audio jacks are not normal fare. for power supply outputs. So this rinky-dink adapter is what I came up with for the voltage output. It goes from a 1/4-inch audio jack to RCA. Then I have this short RCA cable going from an RCA to BNC adapter, and then finally to these test clips. So I should be able to just plug this in, and this would give me my voltage outputs, positive and negative. And I don't have a foot switch, but I do have this 1/4-inch to 3.5 millimeter adapter, and then this dummy plug. It looks like a 3.5 millimeter audio plug, but it's just a solid piece of metal. This was designed for plugging into the microphone jack of a tape recorder when you want to erase a tape. This would just make a blank recording because there's no signal, it's just shorted. So this would short the foot switch jack, and that would turn on the power supply whenever I have this plugged in. So as soon as I plug this in, I should get my voltage out of these test clips. So here's the first test. I have the output of the power supply connected to one of these Philips light bulbs, and when I turn it on and stick in the dummy plug, the light bulb should light up. So here we go. And it does. So the power supply works. I'm not sure of the exact voltage or wattage rating of this light bulb, but by turning the knob on the power supply, I can get it to range from barely glowing to very bright. Now I want to put a meter on this thing to see how accurate its meter is in terms of its voltage output. Okay, I have the meter connected. I'll turn on the power supply. With the knob turned all the way down, it's putting out 1.55 volts. And with the knob turned all the way up, it's putting out about 16.1 volts. So that's the range. Now let me see how accurate this little meter is. I'll set it to what is an indicated 5 volts on this meter, and it's putting out more like 5.7 volts. And an indicated 10 volts on the power supply's meter is almost 10 volts, 9.8 volts. So the meter is not quite perfectly accurate, but it's pretty close. Now I want to take this thing apart and see what's inside, because you may have noticed that it doesn't have any cooling vents or any kind of external heat sink. And in my brief testing, I could feel it starting to get warm on top. That and the fact that it was designed to be operated by a foot switch might suggest this was really only meant for intermittent light-duty use and would not stand up to delivering its full output current rating for continuous duty use. Well, that's about as basic as they could possibly make it. It's just a power transformer, rectifier diodes, filter capacitors, and a voltage regulator chip. And that's really it, aside from the meter and the adjustable knob to control the voltage regulator. The circuit board has a date of August 3rd, 2011. And coincidentally, I'm recording this video almost exactly 15 years later. The voltage regulator chip is heat sinked to the bottom of the metal case, which is good. But despite it having a 3-pronged grounded power cord, I don't see any ground wire actually coming out of it. I only see the live and neutral connections. So this ground pin is probably fake. If I do a continuity test with my multimeter, sure enough, put one pin on the ground of the cabinet, another pin on the ground pin of the power cord, and there's no connection. So this ground prong is purely decorative. And the way they lit the meter is rather hokey. They just put a white LED next to it. At least the fuse is properly rated. That's a 2-amp fuse. Now I'm curious to see what would actually happen if you accidentally plugged an audio device into this power supply's 1/4-inch output. For example, a pair of headphones. don't worry, these are just an old pair of Caliphone school headphones with a mono plug. So we're not losing any high fidelity audio equipment here. Okay, got both the headphones and a dummy plug plugged in. Now I'll turn it on and slowly crank up the voltage until something bad happens. If it's going to happen at all. Nothing so far. Don't even hear anything coming out of them. I'll just let it sit for a while. Okay, that's been on for about a minute, so let's turn it off and see if those headphones still work. Well, believe it or not, they do. I got the headphones plugged into my stereo system here, and still sound fine. So no harm done. Well, I could actually use an adjustable voltage DC power supply. I'd like to have one a little bit more heavy duty and well built than this one. But nonetheless, if I do end up keeping this Porkit Indicate T2 power supply, I think what I'll do is hardwire it to be permanently on whenever I switch on the power, and then replace these two 1/4-inch jacks with proper banana terminals for the positive and negative outputs. That will make it a lot more convenient.